Welcome to the Module 8 presentation for CIS 288M. In this presentation, we're going to be talking about Chapter 12 of the In and Out book, which is covering storage management and Internet Information Services, also known as IIS. So let's go over what we're going to talk about in this lecture. First, we're going to talk about storage. Then we'll move on to volume shadow copy service. Look at some command line tools we can use for managing storage. We'll discuss performance, capacity, and availability requirements for Server 2012. We'll look at RAID and some of the various RAID levels. We'll discuss iSCSI, target initiator, and services. We'll look at failover clustering. We'll take a look at the difference between a SAN and a NAS. And we'll talk a little bit more in detail about storage area networks, SANs, or network attached storage, NASs. We'll look at a hybrid NAS. We'll talk about MBR and GPT. We'll look at ways that we can connect to outside storage. We'll discuss multipath input-output. We'll look at IIS networking and talk about what IIS is. We'll take a look at the different types of websites you can create with IIS. We'll look at how IIS uses different ports. We'll also look at bindings and host headers, and we'll briefly discuss virtual directories. So let's talk about storage. So in the context of the Windows environment, storage refers to disk storage. So storage no longer needs to be inside a server to be a drive letter. So it doesn't have to be internal storage. Internal storage devices are also can also be referred to as direct attached storage devices. In the case of a DAS or direct attached storage device, even though it's technically internal, the storage or the physical storage may live outside of the physical server. So you might have a big set of drives that are plugged in via a DAS cable to your server to expand the storage that it can possibly have. So there are some options for external storage options. So we've got two options here. We have a storage area network, also called a SAN, and we have network attached storage devices. So we're going to talk about those in detail here in a few slides. You can access storage either in the server manager or in computer management of your Server 2012 server. You can also add in the disk manager via Microsoft Management Console. So let's talk about one of the more useful features in terms of hardening your operating system, or rather hardening your data on Windows servers. Let's talk about volume shadow copy service, or VSS. So volume shadow copy allows administrators to create point-in-time copies of volumes and individual files, and these are called snapshots. Now, those of you that are familiar with virtualization have heard the term snapshots before. And basically a snapshot is just a point-in-time copy of, if we're talking about VSS, it's a point-in-time copy of documents or files or folders or even volumes, and these are referred to as shadow copies. In the Windows environment, they're referred to as shadow copies. But for those of you that are coming from or have dealt with virtualization before, VSS functions a lot like how you take a snapshot of a virtual machine. It's just a copy or a picture of that data at a specific point in time. And one of the things that VSS lets you do is it makes it possible to back up items while files are open and applications are running, and it allows you to restore those files and folders to a specific point in time. A lot of the more common backup technologies, such as Veeam, Unitrends, I believe, does this. They make use of the volume shadow copy service running on Windows for file level backup. So even outside of the Windows world, a lot of technologies rely upon this service to function. So it's one of these great services that Windows has by default that allows you to make your data a little bit more resilient. So the basic VSS functionality is built into file and storage services accessed through the file server VSS provider. You can check to see if volume shadow copy service is running just by going into your services manager on your server 2012 server. You can extend the basic functions of shadow copy in a few different ways. So one of these ways is to add the file server VSS agent service. You can use this role service to create consistent snapshots of a server application data, of server application data such as virtual machines from Hyper-V. So it does have some integration with Hyper-V. You can also install the agent service on a file server when you want to back up applications that are storing data files on the file server. Here you're backing up application data stored on file shares, which is different from user data stored on file shares. So that's managed through the standard file server VSS provider. So any good administrator needs to know some of the command line utilities that you would use to perform certain functions in Windows. And in this case, since we're talking about disk management, we are going to look at some of the command line tools that are available in Windows for managing both local storage and storage replication services. So the first command that we're going to look at is diskpart, and diskpart is used to manage basic and dynamic disks as well as the partitions and volumes on those disks. If any of you have ever manually created a bootable USB flash drive, diskpart is an bootable USB flash drive for installing Windows. Diskpart is a very big part of creating that bootable flash drive. You can use diskpart to do a bunch of different things like format drives. You can you can change the drive letter that a volume is mounted to, so on and so forth. There's a lot of different things you can do with diskpart. Now these next three commands have to do with DFS, which stands for Distributed File System. So DFS is basically, and I think we touch on it here in a few slides, but DFS is basically a way to store your files in a decentralized method. So rather than have one file server set up hosting your data, you might have 3 different file servers set up and they all replicate the data back and forth to each other. This allows you to have quick access to your files no matter which location you're at. This is really useful in larger environments where you might have people traveling between offices a lot. They get quick access to their files with DFS. So these 3 commands allow you to interact with distributed file system. So DFS diag is used for troubleshooting and diagnostic purposes for DFS. If you're running into issues with DFS not working quite right, you can use the DFS diag command to troubleshoot some issues to see if you have any issues with the distributed file system. DFS admin is used to manage and monitor DFS replication throughout the enterprise. So I mentioned that DFS basically allows you to configure multiple file servers to host the same the same set of files. And they have to replicate the data back and forth to each other. Well, you might find that one particular file, when you open it at the Oregon office, looks different or has different content than if you opened it at the New York office. And so sometimes the replication can hang, or it doesn't, maybe it's moving slower than it should, or the file gets locked. So you can use the DFSR admin command to figure out if the replication is functioning as it should. The next command here, DFS-util, is used to configure DFS, backup and restore DFS directory trees, so DFS namespaces, copy directory trees, and troubleshoot DFS. So some other command line tools for managing storage include FS-util. So FS-util is used to get detailed drive information, and you can use this to perform advanced file system maintenance. You can manage sparse files, reparse points. You can look at disk quotas, and there's a bunch of other advanced NTFS features that you can access with FSUtil. It's a really good tool if you are if you're trying to troubleshoot some storage issues. FSUtil can actually help to resolve storage issues. Mount vol, that's used to manage volume auto mounting. So if you have particular set of drives or a hard drive that you want to mount, you can use mount vol for managing that, so that it always gets the same drive letter. VSS admin, that's used to view and manage volume shadow copy service and its configuration. So we talked about VSS a little bit ago, and a few slides ago. VSS admin is the command you'd use to manage that service. So let's talk about the different aspects of a storage system. So performance, capacity, and availability requirements. So storage performance primarily focuses on these three factors here. So disk access time is one of them, and that's how long it takes to register a request and initiate the disk scan process. So once you've said, hey, I want to open this file, this would be the time it takes to initiate that whole process. Seek time, so this is how long the hard drives take to actually find the requested data. And then transfer rate is how long it takes to read and write the data. So we have several different factors that go into figuring out, or that go into determining performance for a particular storage array. Seek time is definitely one of the things that can impact the retrieval of data the most. If you've heard the term fragmentation, sometimes what will happen is your disks will write data in more of a fragmented way. So as they're spinning, they can't write all the data in a single concentric track or concentric circle. So they have to skip over particular sections of the disk to write the data. So your data for your particular file might not all be located on the same physical portion of the disk. So you can actually run that defrag command to force the data to consolidate the data so that the seek time is less. The hard drive doesn't have to go looking in 3 different places on the physical disk to find the data. It can just search for one. It only has to go to one place to get the whole piece of data. So next, let's talk about capacity. So when we're talking about the aspect of storage related to capacity, capacity relates to how much disk information you can store on a volume. So this will be a volume logical disk or a physical disk. So some key points here: the max NTFS volume size is 256 terabytes. Now it's funny because that seems like a lot of data, but as we get further along in the future, terabytes are going to become pretty common. You know, we'll probably eventually see a single disk that supports 256 terabytes, and you might think, well, I'll never use that. But there are definitely applications, even in the small business, where you would maybe end up using that much data. Case in point, my company is exploring video surveillance. And our company operates about 1 million square feet of warehouse. So you can imagine that it takes a lot of a lot of cameras to cover that 1 million square feet. So we need a lot of storage to store all of that video data. And believe it or not, 30 days worth of video storage for all the cameras that we're going to add to our system is going to take up about 50 terabytes worth of data. So here we're not quite there, but we are 20% of the max NTFS volume size. So, you know, again, definitely something to keep in mind. It's not often that you're going to run into that limit, but there's a possibility you could. So that's why we're noting it here. One other key point here is the max file size on an NTFS volume is 16 terabytes. Again, typically you're not going to run into a 16 terabyte file ever, but as we move forward, we may find uses for such large data or large amounts of data. A single server can manage hundreds of volumes. So the theoretical limit is about 2,000, but volumes in this case refers to logical sets of data. So we can have hundreds and hundreds of different types of volumes on our server. So continuing along here, storage availability relates to fault tolerance. So this is ensuring availability for essential applications and services by using availability technologies. So when we're talking about fault tolerance, we're talking about the ability for a system to continue functioning in the event that there is some sort of a hardware failure. So as it relates to storage, at the disk and data levels, availability is enhanced by using a redundant array of independent disks, or RAID technologies. So RAID technologies allow you to combine disks into single volumes, and that helps you improve fault tolerance. And in some cases, it allows you to improve performance as well. So in the next few slides, we're going to be talking about the different RAID technologies. Now, in addition to the hardware RAID technologies we're going to talk about, there are some software RAID technologies out there. Windows Server 2012 R2 does have one called Storage Spaces that is a software-based method to enabling RAID. But that is going to be outside the scope of this particular presentation, but I thought I'd mention it here while we're talking about it. So again, RAID stands for Redundant Array of Independent Disks, and as I mentioned in the previous slide, it can be implemented in hardware or software. So when servers have hardware RAID controllers installed, the internal controller can be used to implement RAID on the server's internal disks. The RAID levels available with the hardware implementation depend on the controller, the storage array, and the vendor's implementation of RAID technologies. In general, the RAID technologies are going to be very, very similar to each other, but some of them support some more advanced RAID levels than others do. So it's important when you're shopping for a RAID controller to keep that in mind. Make sure that it has the functions that you're looking for. One of the drawbacks, though, to using, going back to our first bullet point here, RAID can be implemented in hardware or software. One of the drawbacks to using software RAID is that you're going to be taxing the system's processor a lot more than if you were just using individual disks. So if performance is a concern at the CPU level, you may want to look into a hardware-based RAID controller to help alleviate some of the strain on the processor. So I did mention that there are a few different software RAID technologies available for Server 2012. Again, I want to just briefly touch on these because we could do a whole presentation on each one of these. So one of the options here is traditional software-based RAID. So this is actually built into Disk Manager in different older versions of Windows, and in fact 2012 has this as well. So you can create something called a dynamic disk in Windows, and the dynamic disks give you an option or some of the advantages that some of the different RAID levels give you, but you do it in software instead of in hardware, as you would with a hardware RAID controller. So some of these include spanning, striping, and mirroring. Sometimes these technologies can be really difficult to work with. So one of the great things that 2012 brought us was the technology called Storage Spaces. So this provides a little bit more resilient storage than the traditional software-based RAID technology of a dynamic disk, and it is preferred over the dynamic disks in previous versions of Windows. It gives you numerous advantages in both speed and capacity and performance, capacity, and availability. It also gives you some flexibility because you can actually create storage spaces that are from disks that or volumes that are of dissimilar size. So you could create a effectively a RAID 5 volume off of a 1 terabyte disk and a 500 gigabyte disk and a 64 gig flash drive if you wanted to. Wouldn't be the best, but you could do it with this. It does give you some extra flexibility. So we did touch on this a little bit in a previous slide, but let's talk about it because I think it's important. First bullet point here, each of these software implemented RAID levels that were mentioned in the previous slide, they do require processing power and memory resources to maintain. So if you do enable RAID, software-based RAID, so be it via dynamic disks or via storage spaces, does require some processing power and memory to maintain. So if you're looking to save some hardware resources, so CPU and memory resources, using a hardware RAID controller can be a better option for you. Using hardware RAID controllers, you use separate hardware controllers to maintain the disks. And again, this does take the burden off of the server, and that helps to improve performance overall. So there are a number of different RAID levels out there that Windows can use. These right here are the most common RAID levels. I'm going to kind of go in ascending order here because I think it's important to understand the lower RAID levels before you can understand the higher RAID levels. So we're just going to really briefly talk about what each one of these are, and then we're going to delve into the more common RAID levels here in a few slides. So the first RAID level is RAID 0. So RAID 0 is disk striping, and disk striping uses 2 or more volumes with each one on a separate drive. Volumes are configured to be a stripe set. Data is broken into blocks called stripes and then written sequentially to all drives. So this provides speed and performance without any data protection. The way I like to remember RAID 0 is that it's RAID 0 because it's not real RAID. So RAID again stands for redundant array of independent disks, and RAID 0 doesn't necessarily meet our redundancy rating, our redundant part of RAID. However, it does give us improved performance, but it does not give us any data protection. So if we do lose a drive, we lose all the data on that volume. Disk mirroring, on the other hand, solves that problem, and it uses 2 volumes on 2 different drives, and these drives are configured identically, and data gets written to both drives. So this provides redundancy and better write performance than just a single disk. So if one of the drives were to fail, then the array would continue humming along. RAID 5, this is a more common RAID level, but it's starting to lose some favorability. And it is disk striping with parity. It requires 3 disks, and each volume is configured using something called a parity bit, and it allows you to lose a disk without losing the data. So it does have better read performance than disk mirroring, and it provides some less overhead than mirroring does. But it does have some drawbacks, and we'll talk about that here in a little bit. You can also configure RAID levels so that you have sort of a nested RAID. So in this case, we've got 0 plus 1, which is disk striping with mirroring, which requires you basically to have 4 disks, and it takes the advantages of RAID 1 and RAID 0 and combines them so that you can have the redundancy of mirroring and the speed of disk striping. Same thing with 5 plus 1. It requires 6 disks, and RAID 5 plus 1 is basically 3 RAID, It is basically 2 RAID 5 volumes in a RAID 1 array. So the whole RAID 5 array gets mirrored to another RAID 5 array, and that way you can lose a ton of disks, 3 disks at the bare minimum, without losing your data. So let's talk about RAID 0 in a little bit more detail. So RAID 0 is the striping method of storing data. Data is striped across multiple physical disks. So in this case, we have our 2 disks, disk 0 and disk 1. And let's say we're writing file 1 to our disks here. So basically what's going to happen is the first part of the file is going to get written to disk 0. So that's part A here. And then the second part is going to get written to part B. Now this write happens all at the same time, which basically allows you to effectively double up the speed that that the data is being written to the disk. So it is significantly faster than just a single volume. So one of the great things about, again, that's one of the great things about RAID 0 is that it's great for storage bound applications or storage intensive applications like video editing. So reading and writing is generally a little bit faster on a RAID 0 array than anything else. But let's look at what happens when we lose lose a disk. So in this case, we have part A written to disk 0 and part B written to disk 1. Well, if we lose one disk, so let's say we lose disk 0, then we only have part B of the file, and that's not enough to recreate the whole file. We need part A and B in order to read the file. So if we lose a disk in this array, then we lose all the data on that disk, or on that volume, excuse me. So RAID 1 mirroring, it effectively solves the issue we had with RAID 0 in that it writes 2 copies of the data to your array. So this allows you to take up to 1 physical disk out of the array without any sort of data loss. So hardware failure is less of an issue. So looking down at our example here, we've got 2 disks in a RAID 1 array. It writes file A to both disk 0 and to disk 1. And just to take a look at what happens when we lose a particular disk, let's say we cross out disk 1 here. Well, we still have the entirety of file A on disk 0, so if we were to try to read that file, we'd still be able to get it. It does require at least 2 physical disks, though you can have more in a RAID 1 array. The amount of storage in a RAID 1 array, however, is 1/2 the amount of physical space on the volume. So for example, let's cross out 3. If you had 2 1 terabyte drives, let's cross this out too. If you had 2 1 terabyte drives in a RAID 1, the result in this case would be 1 terabyte of available storage, even though you have 2 terabytes of physical disk space. And again, that's because in a RAID 1 array, it writes both of the your file to both of the disks. So RAID 5 is a little bit more difficult to understand, I think, than RAID 0 or RAID 1. RAID 5 is striping plus parity. So basically what RAID 5 does is it stripes your data across physical disks, across all your physical disks, and then it maintains something called a parity bit. So what a parity bit is it is part of your file, but it is stored on more than one disk. So let's go through the bullet points here, and then we'll look at an example of how this works. So first off, it protects your data a little bit more efficiently than a mirror because you can lose, and efficiency in this case refers to the amount of storage that it actually uses. So rather than it being 1/2 the storage, it's just the amount of disks you have subtracted by one disk. So if you have 3 1 terabyte drives and you put them in a RAID 5 array, instead of losing half the available storage, so you'd get 1.5 terabytes in a RAID 5 array. In a RAID 5 array, you would get about 2 terabytes worth of data. So it's more efficient than a RAID 1, or excuse me, a RAID 1. It does require 3 physical disks, and again, you can lose up to 1 drive, and the array will continue to function. So let's take a look at how this, how a file gets written to the disk. So you have 3 disks here: disk 0, disk 1, and disk 2. And we've got our file a.jpg, so this is just a image file. So what's going to happen is it is going to write part B to this first disk. It's going to write part A to the second disk, and then it's going to write part A and part B to this third disk. So just to illustrate what happens, let's say we lose disk 1. So lightning strike happens, causes the power to go out. When we spin our array back up, disk 1 dies. So in order to reconstitute file A, or in order to read file A, we need both part A and B, correct? So if we need part A and B, well, part A and B are stored on disk 2, so we can recall it from disk 2. And also part B is written here. So let's take a look at another example. Let's say we lose disk 0, or actually let's say we lose disk 2. So if we lost disk 2, again, we need both part A and part B to reconstitute the file. So part B is on disk 0 and part A is on disk 1, and that means that we can indeed read file A. And last example here, let's say we lose disk 0. Well, part A is stored here, and since we're storing part A and B on disk 2, we have the part B that we need, so we can get file a.jpg. Now, one thing to note is that not in a RAID 5 array, there isn't one disk that's dedicated for parity. Parity actually happens across every disk, so there's not like one parity disk. So let's say we had, we have file a.jpg, and while part B is written to disk 0, part A is written to disk 1, and part A and B is written to disk 2, well, let's say we have another file. I'm just going to call this t.txt. In this case, part A might get written here. Sorry, that's a really bad A. Part B might get written here. Actually, let's do this. Part B and part A might get written here, and then part B might get written here. So that is all handled by your RAID controller, but different files might be stored differently depending upon how your RAID controller configures or decides to write data to your disks. Now, this is completely normal. This is a function of RAID 5, and basically what happens is your RAID controller keeps track of where all the data is, so that when you need to recall or read a file, it knows where it is and how to access it. So let's talk about iSCSI. So iSCSI stands for Internet Small Computer Systems Interface. So people refer to it as ICSI or iSCSI. It is storage that you can access over an Ethernet cable using TCP/IP. So I'll let that sink in for you real quick. I'll just repeat it. You can access your storage over an Ethernet cable, so over the network, using TCP/IP. So rather than having a disk plugged into your computer that's storing all of your data, you can use iSCSI to connect to a particular volume over a network as if it was local storage. So this is different than This is different than accessing like a network share or a file across a network. This is basically tricking your computer into thinking that the volume, while stored on another computer on your network, is actually local. So once the storage is attached to your computer, you can give it a drive letter. So Windows will effectively think that it's local storage. So you might have C as your operating system, and then you might have D as your iSCSI storage. Server 2012 allowed a new feature, or has a new feature that allows the server to be either an initiator or a target. So an initiator is basically well, we'll talk about it in the next slide here. So as promised, let's talk about what an iSCSI target is. So an iSCSI target is the storage device itself. So if we're talking about a target, it's the device that we want to connect to. So if we had a server 2012 machine and we wanted to connect up to our iSCSI target, or to connect up to our storage array, we could connect over iSCSI and we would be connecting to the target. So you can now use Windows Server or Windows 2012 Server to be the storage device of another 2012 server. So you load up 2012 Server with as many hard drives as you want, and then you can create one or more partitions. And then you install the iSCSI target role, and then you can set up security as desired to keep other servers from connecting to it. So in other words, we can create a storage server that we can have other servers connect up to. So I'll give you an example here. I have at home, I have a 1U server that is running my Hyper-V environment, and that server only has one physical hard drive in it, and I needed some additional storage space. So what I did was I set up a Server 2012 server to act as an iSCSI target for my Hyper-V server, and now I host all of my virtual machines on my Hyper-V server. Or all the storage for my Hyper-V server virtual machines is actually located on my iSCSI target server, which is a 4U server that has a whole bunch of hard drives in it. So this is really useful if you have a server that doesn't necessarily have as much storage as you'd like and you need to expand the storage of it. So now that we've talked about what an iSCSI target is, let's discuss what an iSCSI initiator is. So this is the basic difference here is the initiator is the computer that is connecting to the iSCSI target. So this has actually been around since Windows Server 2003, and you can use, so if you've got an older server, you can use it to connect up to an iSCSI target. So traditionally, what you'd use an iSCSI initiator for was to connect up to a SAN, so a storage area network, which we're going to talk about here in a little bit. But now, because Server 2012 can act as an iSCSI target, the target server can be the SAN, which can ultimately save a lot of money. Some of these SANs cost, a cheap SAN sometimes costs $15,000. A more expensive one can cost hundreds of thousands of dollars. You can run the iSCSI initiator service, and it will tell you what the IP or what IP the target is on. Connect to the target server, and the storage shows up in disk management in the storage server as if it was a locally attached volume. You can bring the partition online by right-clicking on it, and then you'd format the drive, and then you assign it a drive letter. So failover clustering, or FC, is a role that you can add in Server Manager, and it allows more than one server to have access to the same data resource. So we had talked a little bit about distributed file systems. Failover clustering is a big piece of distributed file systems. So in essence here, if one of your storage server fails, the resource is still available to the other computers. So let's say you have distributed file system, or DFS, and it is 3 different servers and 3 different offices holding one set of data. Well, if the office in Oregon goes down or goes offline, well, the offices in New York and Santa Monica still might have still would have access to that data. You can create a cluster after installing the role, and you can create a common name both servers will respond to in case one goes down. So if you typed, let's just say for the sake of our example here, let's say you had dfsnamespace.com, and that namespace pointed to 3 physical servers. Well, the clients don't necessarily know that the server in Oregon went down. They just know that they're accessing dfsnamespace.com. So it will respond. If one server goes down, the other servers will still respond. You have to set up the cluster storage properly, or both servers will freeze up when trying to access the data at the same time. So if you don't set them up correctly, Windows will think that the data is located on one set of drives or one server, and it will freeze up when trying to access the data because it's actually hosted on more than one server. So this is a really difficult distinction to make, I think, for a lot of people. So again, SAN stands for Storage Area Network, and NAS stands for Network Attached Storage. So let's talk about the difference between a SAN and a NAS. So there are 2 different types of disk storage. We've got SAN and NAS. It's easy to confuse the one for the other. They both provide additional storage for the network. They both provide security and encryption if needed. And one thing to point out, and this is where it gets really confusing, is there are devices out there that will do either NAS or a SAN depending upon how you set them up, which can complicate the concept a little bit further. So let's talk about a storage area network first. So a storage area network, you can connect directly to your server. So it doesn't have any operating system on it. So it doesn't run any file serving. It doesn't do Samba. It doesn't do, it doesn't have NTFS file system. You can't share network drives off of it or install applications for it. It's just there for raw data access. It requires it to be connected to a server like our Windows 2012 servers in order to work. An iSCSI target can be a SAN, or you can buy a dedicated SAN device from the manufacturer of your choice. Again, the dedicated devices can get really expensive. You can set Windows to act as an iSCSI target or a SAN, but it's not necessarily the same as a SAN you would get, a dedicated SAN you would get from Lenovo, HP, or Dell. A network attached storage device, on the other hand, does have its own operating system. So it has the ability to manage users and files, shares storage. You can set up file shares off of it. Some of these NAS devices allow you to set up print servers, all sorts of different things. So it does have more functionality, I guess you could say, than a SAN does. You can connect to it by IP, or you can create a DNS name on your server to point to it. You can map drive shares, but you don't create drive letters as you would with a SAN. So NASs are typically less expensive, and they can run on Linux, which doesn't necessarily make them buggy, but it can be a little bit more difficult to connect to with Windows PCs. NASs, again, are definitely cheaper. They're a good way to add storage to your network, but they don't perform the same as a SAN does. So the real difference between a NAS and a SAN is the underlying technology of a SAN allows it to operate as fast or at the same performance level as if it was local storage. So storage that was hard drives that were connected up to the internals of the computer, except it's operating over a network versus being plugged in with like a SATA cable inside your computer. So that's the difference between a NAS and a SAN. A NAS is really easy to get set up and it's flexible, but it's not necessarily, or it's not nearly as fast as a SAN can be. So then it can get a little bit hazy here because they do make hybrid SAN/NAS devices. So some devices have all the built-in operating systems like a NAS does, but it can be used as a SAN, such as a SAN as if it was like or connecting up to iSCSI. So for example, there's this QNAP device which you can use, and the SAN the hybrid SAN NAS or this QNAP device allows you to set the device up as an iSCSI target. So it could be a SAN or a NAS depending on how you look at it. Now it's typically not again as fast as a dedicated NAS, but because it has iSCSI, it allows you to connect up to it as if it was local storage. So with these types of devices, you can set it up as a NAS, or you can set it up as a SAN, or you could set it up as both and it just functions like you want it to do, or like you want it to. But again, the storage performance is not the same as if it was a raw SAN typically. So while we're talking about storage, I think that it's important to talk about the master boot record and GPT, which we'll talk about here in just a second. So the master boot record has more than one meaning in Windows. So let's just talk about it here. It can be the file that Windows uses to point the way to Windows during boot, or it can be the type of drive formatting when used to create a partition. So it's really a partitioning scheme. It's typically located at the on the first sector of a disk, so it has sort of a dual purpose. So when the machine's booting up, the MBR can point the computer to Windows, and then Windows can load from there. And then it's also set up as a formatting scheme or a drive formatting scheme for creating partitions. The MBR or master boot record is the legacy option, and it tops out at 2 terabytes because it's based upon an older technology. However, even though it's the older option, it's still the most common. And one of the things that you should keep in mind is that currently Windows can only boot off an MBR formatted partition. To my knowledge, it can't currently boot off of a GPT partition, so it has to be formatted with MBR. GPT, on the other hand, stands for GUID partition table. GUID in this case stands for globally unique identifier. So this is a newer technology, and it allows you to go to partition sizes we have yet to manufacture. So really, really big partitions. So this is what you'd use when creating new larger partitions in disk management. And one of the great things is you can convert between MBR and GPT, just as long as you don't have 2 terabytes of data or more than 2 terabytes of data on a GPT partition to go back to MBR. So really, the main reason we would use GPT partitions, there are a lot of other advantages to using GPT. But the main reason is if we had a volume that was larger than 2 terabytes, we would just format a GPT because Windows doesn't allow you to do anything else. So this should actually be a few slides ago. So we talked about a SAN. There are many different ways that you can connect to a storage area network. So again, a SAN is just that. It is a network that is set up for just storage. So you can connect up to it with fiber. You can connect up to it with a protocol like iSCSI or SCSI cables even. You can connect up with SAS cables. So these are typically what you would see in higher performance servers. You'd see like SAS drives. or you could connect up with a direct cable, which is kind of like the legacy method of doing it. And in that case, it's not technically a SAN because you're not addressing it over a network, but a direct cable allows you to directly connect one machine to one storage area network. So those are the main ways that you would connect to outside storage. And in this case, outside storage refers to storage outside of your physical machine. So in this case, a SAN. So this is a feature that's actually super cool in Windows. It's multipath I/O. So multipath I/O can be used for redundancy. I'm all about redundancy, and so this is definitely a good feature to have. This is a feature that you install via Server Manager, and what it allows you to do is it allows you to connect a partition from a single device to a single device from more than one connection. So for example, if you have two Ethernet cables and your NICs connect to an iSCSI device and one fails, well, then the other one sort of will pick up for it. So say again, needing to be highly available is a big thing in IT now. You want to have as much uptime as possible, and creating different paths to get to the same location is typically the way to do it. So in this case, let's say we have I mentioned that I work in a warehousing environment, so we have all of our forklift terminals connected up to a set up to connect to a storage server, and let's say or a warehouse management server, and let's say that management server requires it stores its data on a SAN. Well, we don't necessarily want our data to go offline should the network interface card in the WMS or the warehouse management server to fail. So what we could do here is we could set up multipath I/O so that when we connect up to that SAN, we are creating multiple connections to that same set of data. So that in the event that one Ethernet cable dies or one of our network interface cards dies, our server is still able to function correctly. So, again, wherever possible, you want to eliminate single points of failure, and this is one of those technologies that allows you to do that. So that's the storage section of the lecture. Let's talk about IIS, or Internet Information Services. So first off, this lecture is not a lesson on how to make a web page. This is more of a lesson for how IT administrators should manage Internet Information Services. Just because you're not a web developer doesn't mean you won't be called upon to manage the servers and the software platform that websites run on. So it's important to know how to manage that and how IIS uses or how applications use IIS. So for setting up special networking scenarios, you're in lab 7, you're going to be using, or in your lab for this week, you're going to be setting up IIS. So we're not necessarily using it to make a website, but we are using it for practicing the administration piece of it. So one important piece here is that IIS does use TCP port traffic. It does not utilize UDP port traffic. And IIS can be secured with certificates and permissions. So if you do need to secure your website that you're creating, you can set it up with SSL certificates, and you can set it up with permissions as well. So what is IIS? IIS stands for Internet Information Services. And initially it started out as just a simple web server for serving up HTML pages, but it has grown to do so much more stuff. So for example, IIS can function as an FTP or file transfer server. It can serve up different web-based applications. Heck, you can use IIS to serve up non-web-based applications too. a lot of the newer technologies in Windows Server allow you to, or make use of IIS for this, such as, oh, the name's escaping me at the moment, remote desktop services. You can also use IIS as a online shopping cart too, so it has some functions for e-commerce. So just in a nutshell, IIS has grown to do a lot more than just serve up HTML pages. So there are three different, I guess, terminologies for websites, and we are going to talk about what each one of these different terminology pieces means. So the first one is just an internet website. So this is what typically people think about when you say, oh, go to this website. It's used by people outside the company and sometimes inside the company to access information about your company. It can be a simple site using just HTML, but it's not limited to just HTML. You can use PHP, you can use ASP, jQuery, JavaScript, anything you can think of that a website might make use of, IIS does support. You can connect it up to a database on the back end for interactive logins and information that shows up on the front end. So I'll give you an example for something I did at work. I set it up so that we have a bunch of temperature probes all throughout the warehouse, and we kind of need to know these temperature probes are web-based, so they report up to a cloud, and we needed to know we needed to compile the information in a specific, easy-to-read format. So I created a website that connects up to these temperature probes, pulls the information into a database, and then displays the temperature information in just a really quick and easy to use website for our employees to access. So again, you can use IIS for a lot of different things, like connecting up to a database, logging in, things like that. So an extranet website, this is basically the same as an internet site, except that it's typically for customers to access secure data. So rather than a website that you normally would go to that just has data up on it, this would be behind a login portal. So if you've ever gone to a company's website and you've seen like a customer login button, this is basically an extranet. So it could be a way for customers to place orders. It could be a way for clients to access information about themselves. If you have accessed like your insurance information, or maybe heck your bank, this would be technically an extranet website because it is behind a username and password. It almost always ties into a backend secure database, and it often uses public certificates for secure compliant login. So your information or your username and password aren't sent across the internet in plain text. So it'll use security certificates to take care of the security piece of it. Now, intranet websites, this is where a lot of people get confused. Intranet websites are sites that are used internally by an organization. So typically these websites are not accessible from outside of your office. You usually make these sites for your own people in-house. It can contain company information, photos, events announcements, much more. If you've ever used SharePoint, SharePoint's a really good example of this, and it's typically internal to your network. Intranet websites are typically not secure, so you might not use SSL certificates for intranet websites because they are local to your company's network. They can't be accessed outside of the office building, but you can secure them using security certificates if you are required to by law, if your HR department requires it, so on and so forth. Again, you can usually only get to the intranet when you're inside the LAN, so inside the office, or while you're using a virtual private network. So let's talk about IIS and ports. So again, TCP/IP is used for the connectivity to all websites. TCP is connection oriented, which means that if a packet is lost in transit, then the TCP protocol states that it will contact either the sender, or it will contact the sender, so the person that sent the traffic, to resend that particular packet. So that's what connection oriented means. UDP, on the other hand, just sends data as it comes through the pipe, and it doesn't try to do any error checking or correcting. You can change the port number to obfuscate the site, and if more than one site is on IIS and you're not using a host header, you can use ports to direct users to the correct site. So if you have two websites hosted on an IIS server, you might have one running on port 80. Which is the default HTTP port, and you might have another running on port 81, and people will connect up to it via the port number. Again, by default, a website listens on port 80. It can listen on any one of the 65,535 ports instead. So again, you can configure it to listen on whatever you want. By default, HTTPS, which is the secure version of HTTP, typically uses SSL certificates. That listens on port 443 by default, but again, that can also be changed as well. So kind of going along with the last slide, let's talk about bindings. So in the top right-hand corner of IIS, there is a link for bindings on every site. So here you can change the port that the website listens on for both HTTP and HTTPS traffic. This is where you can bind a certificate, so like an SSL certificate, to the port for secure traffic. And you can also add host headers, which we'll talk about here in a second. So if you want your website to listen on port 8080 instead of port 80 by default, this is where you would go to change it. There are a number of reasons why you would want to change the default port. Again, it's arbitrary. You can use it to sort of hide your website. So if you don't want people to connect up to it, or if you want only certain people who know the URL to connect up to it, they'd need to know the port number as well. You might also have an application on that particular server that's already using port 80, so you can change the bindings so that the website that you're using or trying to set up on this server uses a different port. The only drawback to this is it's not as easy for end users to connect up to it because they have to remember a port number. So for example, when they type in google.com, if google.com was running their search engine on port 1337, then in order to access it, you'd have to type google.com:1337. So it's just a little bit more of a pain for end users to have to remember that in addition to the DNS name. So here's where host headers comes in. So before host headers, you could only listen on port 80 for one website. So if you had a need to host more than one website, you had to have more than one IP address set up on that server for hosting said website. Which could be a major pain in the butt, especially for people that needed to host, 10 or 15 websites on a single server. You'd have to have multiple NICs, you'd have to have multiple servers potentially. It could be a huge pain. So host headers, basically what it does is it divides port 80 up by name instead of port number. So for example, if you have a website A.com and B.com, and they're hosted on the same server, rather than creating a different IP address or adding a different NIC to that server for that particular website, you could simply set it up so that both A and B.com listen on port 80 by default, and then you'd add the host header names, so A and B.com, to each website under the bindings, and then IIS will automatically redirect the traffic based upon the name that the end user puts into their web browser. So even though A and B.com are both hosted on the same server and traffic is going over port 80 for both A and B.com, IIS will redirect the traffic so that the end user is none the wiser. So host headers really solves the problem that we had before, which is if you have multiple websites on a server, having to use different port numbers or different IP addresses or multiple NICs, it really makes it a lot easier from an administrative perspective. So virtual directories are another form of organization for a website. This allows multiple sub-websites using the same host header name. It depends the host header domain name. So for example, if we had A.com and we wanted to host a website company and intranet for the same domain name, we could create a virtual directory that would redirect users to that URL. So in this case, these last two domain names are regular host headers with an appended subfolder, and these folders can be it can be in any folder on the server you want. So that's the piece that's really interesting. So typically with a web server, you'd have your index.html, and then you'd have in that same folder, you'd have a folder for pictures, and then 1.jpg, and so on and so forth. So rather than if we wanted to add company to our IIS server, rather than having to locate them in this same directory here, company could be located anywhere else on the computer. So it doesn't necessarily need to be located in the same directory that this first index HTML page is listed. So we covered a lot of topics. Let's just recap really quick here. A large part of what we talked about this evening, or in this video lecture, was storage. We discussed the volume shadow copy service and how you could use that to create some resiliency for your files. We looked at some of the command line tools that you can use for managing storage on your system. We went over the different aspects of storage and how to evaluate those. So looking at performance, capacity, and the availability requirements. We talked about RAID and the various RAID levels. We went over iSCSI services and discussed the difference between a target and an initiator. So a target is where the data is actually stored, or where the storage is actually happening. The initiator is the computer connecting up to the target. We talked about failover clustering and how you could use that to, again, provide some more resiliency for your network or for your data. We talked about the difference between a SAN and a NAS. We also discussed the various aspects of storage area networks and network attached storage. And we discussed how hybrid SANs and NASs can kind of confuse the layman to what a SAN or a NAS, the distinction between a SAN or a NAS. We discussed the difference between master boot records and GUID partition tables. We talked about the different ways to connect to outside storage. We talked about the great technology of multipath input-output, again, providing you with some redundancy for connecting up to storage. We briefly discussed IIS, and we talked about what it is and how different website or the terminology for each different website, a type of website. We talked about how IIS uses different ports. We discussed bindings. We discussed the advantages of host headers, and we also just talked about virtual directories.